Okay, let's go. Speaking about container, virtualization, and everything, and how does this thing compare to each other, and I will try to do all the demo from all my mind because the speaker doesn't work. So, yoo-hoo. First, my name is Quentin Adam. I'm CEO of a company called Clever Cloud, and I have a very unpronounceable handle name on Twitter, which is really great because nobody has stolen me along the year, except someone stealing me on a Pokemon Go. So if you find wax on Pokemon Go, just ping me on Twitter. I find this guy. I want my handle back. My day-to-day job is quite cool. Oh, it's a little bit stretchy actually. Maybe I can expand a little bit if you give me a second. Doom, 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 doom. So, this way, okay. So, you can still read, okay? So, and my day-to-day work is manage a company called Clever Cloud, and what we do is keeping your application online. So you just git push, and after we deploy everything. So, and we monitor, we relaunch stuff, we expand resources, go back resources, and we do that for bank, insurance, and everywhere in the world. So we called it the Department of IT Automation. And we learn a lot of good stuff about good pattern, bad pattern, doing that. And doing that, we decide to give back to the community and make a lot of talks to explain what we do. So, why we still need to talk about virtualization and also technology like containers. If you think about it, like years ago, like 40, 50 years ago, computer was really big like the size of this room, and was really little capacity. So basically, you have a program in the computer, you put it, computer process, and after a few hours of process, you get the results. But the thing is, computer becoming more and more powerful, and at the time, it becomes so powerful that we're starting to think about running several software in the same hardware. You know, like not only begin at this instruction and there, but have some multiple software there, and to manage that, we invent the process. And to manage all the process, we're starting to create the first software to start inside a computer, which is the operating system. And the operating system first task is to manage the process. Okay? Process scheduling. Do you remember the Great War? Who remember the Great War between Init 5 system and System D? Yeah. Who have actually get what this war was on? Okay. Basically, what's happening there was system Init 5 was something who actually was the first process to start inside your Unix, and after have the role of starting the other's process and managing their life. It was really simple. It's a software from the 80s, you know. And as it was really simple to manage stuff like in which order we have to start the process, like for example, if you have GitLab, you need to start Redis and Postgres before starting the Ruby stuff because you cannot connect to the database and fail. You know, just order what process start before when. Like there is nothing in system init 5, people was doing it by bash. Something like 800 lines of bash. So scripting. And systemd people basically thinks that, okay, ordering the process is something we quite do every day. Maybe we can code something who semantically we describe that. The problem is ops. Who is ops in the room? Like day-to-day ops and not developer? Okay, I can say bad things. Okay, so the problem with ops is they don't like change. Systemd is here for 30 years. Why changing it? Because it's better. I know. Why changing it? No, wait, we can improve your work. No, why changing it? So basically, it was the point of, I have been last 10 years managing and puppeting all this bash script. I like them. So I will not remove it. Yeah, but we can do the same thing of your 800 crappy bash with five lines of configuration. No, this is my baby. We'll never kill it. If you like to write some code, just become a developer and fuck it. Okay, so one of the big goals of the operating system is the process scheduling. Okay, and when we say that, the first things to say with that is Unix have made a quite good stuff around that. So basically, it becomes cool. Then comes the ops spaghetti management. Who remember the mod GK with Tomcat and Apache? Who actually gets how to install it in a Debian? Complicated stuff, isn't it? This kind of servers we have built over the years with, there is a database somewhere, but we also start another PostgreSQL in a different version for the other software. And we also have a varnish somewhere, but we don't know when. And since we have problem with Apache doing the reverse proxy, we also start an Asha proxy on top of that. And when you're going to PassOx is the command to list all the process, you're just like, what the fuck, what's going around with this server? This is the spaghetti ops management. So we're starting to decide, we need to delink that and find a way to unlink the hardware capacity from the software and the software and have a way to manage things differently. So when we're starting to do that, the first way we do was the process. Process works very well, except the isolation. If you start a process and start another process, right behind together, they can talk to each other. They can kill the other one. They can write to file of the other one. They can try to do anything with the system interruption stuff will have action on the other process. But also it can be another stuff. If one process gets really busy and it's all the hardware capacity, the other are nothing to it and perish. So this is the first problem. The other problem is the software dependencies, only in Russia. Software dependencies is when you start, for example, your application with Java and GBoss, you need the GD key somewhere in the operating system. And sometimes you need to start a web sphere, so you need an old GD key somewhere in the operating system. And have multiple versions of the same library or tools in the same operating system is a fucking nightmare. Isolation of software dependencies is quite important. The other point is the security. Security is complicated. Election of Trump. Security is a quite complicated stuff because you don't really know what's happening. So you try to figure out a very simple number of rules to be sure that nobody is adding on the other stuff. Few years ago, Geoffroy from Clever Cloud wrote a very cool blog post named "The End of the Fortress Metaphor." Majority of security people in the IT thinks if you build a fortress with the cool enclosure, nobody can get in and you're safe. The problem is it's false. Because there is various ways to get in. And when you get in, and everybody is okay to say, okay, if you're in the fortress, you're a friend. The problem is you don't have in-depth dependencies, in-depth security. So the in-depth difference implies that every component on your IT needs to be treated add a potential log. It's very important to get that in mind because I will explain a lot of stuff about container today, and the in-depth dependencies is one of the most important stuff. Hardware resource access was what I was explaining. Sometimes you need to have different hardware resource access and to be sure that one process can have it. So this is the isolation as it has to be defined for several processes. And the first way we tried to isolate stuff was shrouding. What is shroud? Shroud is a way to say, okay, we're in Unix. Just do something simple. We change the slash of the root of the file system. And when we change that, for an entire context of process, at the root it changed, it will be isolated inside its own directory arborescence, or directory tree, you know, and it will be okay. And as in Unix, everything is file. Everything has to be defined as a file. Okay? So, here first comes the first demo. And I discovered that I haven't started. So,
can you make it bigger?
Yeah, I can make it bigger. I always can make it bigger. So yeah, I'm using Vagrant for that. Why we're starting that, my own quick, just a quick sondage. Comment on dit sondage? I don't remember. So, poll. Who knows Clever Cloud already? Okay. Who use Clever Cloud already? Oh, cool. So, I have a lot of work to do to convince you to use Clever Cloud. So I'm in a simple Linux, okay, and I'm creating. I'm in simple stuff. So I will just start a server there. So we're just starting a server, very simple there, and yeah, sorry, just one with Surface. And if I curl there, and I will see there is something running, okay? But the point is, this Node.js app have a failure, so I can access it, in fact. And if I running curl like, I'm not sure, but I think I have history, so I can. There, okay. So if I'm doing that. The first is, okay, I can execute code. But if I'm doing stuff like executing, creating a file inside CMP and call it f like that, and going there, I see there is my file. So it's a problem for the old stuff. So what we do when we shroud is changing the root of that. So what we do is, oh yeah, fuck, I have to take all the process management, Unix keys. No, I haven't. Oh, this is not cool. This is absolutely not cool. Ah, see, yeah, I have it. So, if I'm going to the inside MNT, I have a shroud directory called base. Okay, to be sure that everything works, I have to mount all the pseudo file system of the system. So basically, I need proc. I will also need sys. I will need dev. I will need lib. No, this is not fun. Why are you not displaying stuff there? I want you to display stuff there.
Back? No?
I'm back. It works. What is it displaying? I don't know. Okay. So I need lib64. And I will need also, yes sir, I'm so sorry to all this stuff. I have stuff to create it automatically when I do the stuff. And then when I shoot it, there, when I launch the shoot, I don't know. What the fuck? Maybe a start to mount bin, yeah. Maybe. It can be there. So, when I shoot there, if I hit to find what slash is, I see I'm on the shoot. So everything I will do inside a shoot will not be able to infect other parts of the system. The problem with that is I'm still on the system. And to be able to shoot, I have to be a root. So basically, if you feel you're safe with this kind of stuff, it's false, because you still have access when you try to get all the mount to the fact that you are in a shoot. And knowing that, what you can do is simply shooting yourself in jailing you in the previous stuff. So you rush root inside the root, but on a previous level, and you're back on the root. Okay? And this is the problem, is you feel safe, but really to be able to shoot, you have the possibility to unshoot yourself. So it was one of the biggest problems we have with this kind of approach, and that's why shoot was downsized through the year because of problems. But what's happening is people starting to think how to improve shoot. Did you have heard about jails and containers? Jails and containers are made of something very simple. Over the year, you're listening names like OpenVZ, Linux vServer, Docker, Arcati, LXA, everything, or systemd spawn now, and they all are the same stuff, which is exactly the same runtime using the kernel. Basically, the technology of container using LXC, Arcati, systemd spawn, or Docker is exactly the same thing. Same security, same problems, same environment, because you're running everything on top of the kernel. Okay? It's just sugar around. It's not really where the stuff happens. So when people say, we will implement a container system, we have to make it with a low-level language, it's false, because it's only making calls to the Linux system. You can build a container system with Java if you want. Okay? It's all run with few technology in the kernel. The first one is the namespacing. Namespacing is very cool stuff. In fact, namespacing is the ability of the kernel to say, for a process tree, so when you're in a system, you just hit the PS3 stuff and you see the process tree where you are. In the process tree, you can lie about things. So you build a map online, explaining. The first namespace is MNT, saying a mounting point can be another name. MNT basis will be called / for this process. But you can also do the same thing for PID, the ID number of a process, and making a map of fake ID for a process. For all the stuff on network, UTS is the same thing on network, it's host name and stuff like that on IP. IPC, which is the way of process interruption get through other processes, is for preventing to sharing memory between two containers. Users ID, so you can basically making someone root inside, which is not root in the system, and every namespace can be linked to something called a C group, and the C group is more like a tag or a label for a point of view of namespace. And it's a technology from the kernel who will be interesting in the future, which is able to restrict the consumption of hardware inside one hardware. On top of that, we're using a lot Linux capabilities, which is the ability to split the right of root between several stuff, to not give the full right of the thing and not using root every time you need an administrator level right. So if you're looking at this, Linux containers are only Linux process. So when you see a box of method with nothing we can go out, it's nothing like that. I will give you an example coming from, I don't know what's running there, but if I go out from there, I have launched a Minikube, which is a Kubernetes cluster. So basically, dashboard. So I have a Kubernetes cluster running-ish, maybe. Please respond me. Are you died? Maybe he's died. He doesn't respond to SSH. Never a good sign. This talk is complicated. Everything is running out. Profile, server, status. Status is unknown. Nice. Would that look at us? No, not from there. Not again. Okay, cool. I will restart it. If I'm going to use, for example, this one. So this one is is running somewhere. I don't know where this is running. So where? Okay. It tried to stop my Kubernetes cluster. So when we say it's only Linux process with a bunch of special permission, what it means it's your Java is actually running among the MongoDB, among the MySQL, among everything in the same process. And the number of processes is increasing. And as you require special permission for everything, everything is running on the root by default. So your Java WebSphere is actually running root. Okay? It's the important point. I will show you in a second when Kubernetes will restart if he agree to restart sometime. Okay. There is a Minikube kill somewhere, or logs, SSH, status stop. I hope it will start at some point. Maybe I can kill it manually. Just give me a minute. Kubernetes is a very, very complicated stuff. You don't want to be show doing bad stuff. You find a way to saying no, it's not my fault. Can I just kill it there? Okay, you don't want. Okay, so the bunch of Linux process we're using means few stuff. So there is isolation and side effects. Each process is a file on Linux. Okay, so if you going to the, I don't know which will be working as a demo there, but if you go to the /proc/ for example, 1, which is a PID, we will see each stuff there. And all the namespace are described there as a directory tree. And the point is, each time you're starting a new process, you will create a bunch of files, an open file. And each file open needs to be somewhere in the system. And the number of files open you have in your system is limited. What means is the number of side effects are so impressive. For example, means that you have a MongoDB or a React cluster running on your system. The React open a lot of files, okay? And you have a WordPress. The WordPress is using fastCGI. fastCGI is using a lot of process because it's starting new process with workers. If your React holds the ability to open file in the system, your container will not be able with the fastCGI to run more commands. And you will not understand why. Just because you have thousands of processes running inside the operating system, it can be a level of side effect you don't know. That's why you have few stuff you need to understand with that. For example, entropy. Each time you make crypto, and for example, HTTPS, you need to have random stuff, to encrypt stuff. All your containers are sharing the same seed of entropy. If one of the containers takes all the entropy will become predictable. So one container will be able to predict what all these containers will have as random number and be able to decrypt all the flux. This is the kind of weird stuff you can do because you're pushing the limit of the container of the operating system very, very, very far away. Do this restart or no? It's just trying to continue to stopping it. Okay, cool. And I cannot kill it. Okay, it's starting a virtual machine now. Yeah. The other point you need to understand is the number of possibility of fails in the operating system is wider and wider. This is why container is an old technology. Because for years, people try to patch it because it's a problem. Because the problem is how to define a way to just isolate stuff easily enough. And this is the same problem for everyone there. So if you think about this, managing process like PID1 is one of the problems you need to address when you're doing some Docker. We have already made some Docker file here. Okay. Have you built your own Docker file? Do the entry point is something like waitforit.sh. This kind of weird stuff you need to do just because inside the container there is no PID1. The PID1 is only the process you boot. And this is why you have so many problems of detecting which process is dying or not dying, because there is no more managing of process inside the container. That's why it's such a problem to manage Docker stuff. If you're looking at what systemd have been spawned with systemd in spawn, you have a way to detect you are inside a container as systemd, and you will run another systemd inside the container. We will connect to the previous systemd, and your old process your old tree of process will be becoming fluent. That's why it's very important to manage this kind of stuff, because the various way of the container fails over the time made a big problem. The other problem is the link between the container and the operating system. If you're looking at it, container is only binary. Means that it cannot be native. And if you, well, it's only binary. So if you look at it, you have the glibc. Everybody see what is a glibc? glibc is a standard library we all using with C. glibc is tightly linked to the kernel. When you're building a Docker in a container, you're taking everything in the OS except the kernel. When you're starting the glibc, we have not been compiled with the kernel, with another kernel, the numbers of possibility of fails are just enormous. You can do that if you really have dependency tied here. But if what you do is Spring Boot application, Spring 5 is running well on every GDK 8, 9, and 10 stuff. So you actually taking the risk of having a bad kernel glibc integration for a not good reason, which is Java with underling. You know, Java write once, run anywhere. It's still true. So this is one of the weird stuff you have to managing when you're in container world. The other stuff is the shared kernel. Basically, every container shares the same kernel. If one of the containers kills the kernel, everybody is dying. So all this problem, and for example, the native stuff, you know, when we say Docker for Mac is native, this talk is killing me, really. When we say Docker for Mac is still native, what's happening is they're starting a virtual machine, and you're running inside the virtual machine. So basically, what's going around, it's binary. You cannot be native to every step. If you have the Java, for example, as a target, and running a Java application inside a JDK on your Mac, it will be native. So that's why it's complicated to say container is a good way to package everything. And that's why it's complicated to say it can be good for monitoring. When you're building monitoring stuff, basically what's happening is you harvest data from /proc/dev. And when you're inside a container, you don't have access to that. So that's why all the monitoring solutions on container are only applicative monitoring solution, because you cannot harvest data from the system, because you cannot have access to this. And all of this problem together meant that nobody wants to rely on that before Docker. Docker comes not because of a need of a solution to running containers. Docker comes because of the pricing on AWS. Let me explain that. AWS say to you, you can use virtual machine when you want. But if you spawn little instances of AWS and stop it and start it and stop it and start it, it's very expensive. So what you do is buying large instances per year, which is way more cheap. But when you have large instances, you need to split it. And that's what Docker step in. But at the beginning, it was not a technical problem. It's a bookkeeper problem. Interesting stuff. So, the search is not over, and now I will describe how works virtual machine so we can understand the difference between the two. At the beginning, this was something called emulation. Who have tried Dolphin? You know, emulator for GameCube, Nintendo, and everything inside is Mac. Fine, isn't it? This software is working basically like this. Creating a fake CPU and running an operating system on top of it. It's awesome because you can fake a CPU you don't have, but it's so slow. And one of the guy building that is, in fact, in Linux, you have something called QEMU. We're doing that. It's the same guy who have built FFmpeg, which builds VLC and all this awesome stuff. This guy is very clever. In fact, the first very, very interesting stuff he does was something, there was a press release from Japan of people with the third supercomputer of the world making the most of the P calculation. You read the paper and say, I think I can do better. And 1 week later, he writes the code on his laptop. He breaks the number of decimal of P, doing by the teraflop computer in Japan. Yeah, very clever man. And QEMU is exactly that. In another way, at the same time, people trying to build Xen. Xen is a parameterization method. So you have one kernel and a small operating system, and it's starting all this kernel like it is a software. But you need to edit the kernel to do that. The kernel of a guest need to be changed to do that. So it was really painful to administrate. And we can make faster using something Intel does like 15 years ago, called the VTX. It's a set of processor instructions. We can quickly say from the computer, change your context. It's changed the entire context of a CPU, and it's allow you to do something really awesome. It's an absolute separation of software inside your CPU. And it's a set of Linux instructions who give you access to the hardware, and the operating system doesn't know they run as virtualized. So you don't need to edit the operating system, and the operating system doesn't know it's virtualized, which is so awesome. And that's what the VTX instruction does on the processor. And doing that, people take QEMU, give the power of that to QEMU, and say, oh, okay, it works. So now we can use it in production and called KVM. And KVM is the using of that. So you have a full isolation of everything because you didn't share anything but the CPU. Okay? So that's a very, very interesting stuff. And why it's important is because of stuff like dirty code. I don't know if you remember, but it's a very big failure in the kernel who allow you to coming from one container and going to the root or to another container. You all think this is very rare, isn't it? Weird stuff doesn't happen often. So when we do security, we don't do security saying like what we build is impossible to break. We do security using math. This is, can you see it? This is the number of failure, security failure of the kernel through the time. So basically, through time to time, you have all the failure of the kernel there. Okay? Last year, it was a really good year with more than 400 security issues on the kernel, with only 36 giving you access to better privilege, which means being a user becoming root. 36 is more than 3 per month. Okay? This is the number of failure you have on the kernel. This is the number of failure you have through the time to KVM. Did you see the difference there? When we say container is not safe for production on shared environment, that's what we mean to say. Because the kernel is largely attackable. Okay? And this is why we have a problem with that. Often people talk to you about performances. Performance is a very interesting subject because basically when you have performances issue, you need to discuss what is the bound. And the bound is not the RAM. RAM is cheap, memory is cheap. CPU burn is really rare, so you don't have a problem of CPU burn. And it can be, for example, the I/O, so the storage and the network. Today, all your problem of performance is like 99% of the time have problem of I/O. Because what is your application? Basically, your application is something coming through the database, on the hard drive, going to the web, on the network. It's not a problem of CPU, it's a problem of I/O. And when you look at this, you need to get these numbers in mind. When you're inside a CPU, getting access to data inside the CPU is 0.5 nanosecond. When you need to talk to the memory is 100 nanosecond. When you need to talk over the network, we speak in nanosecond, in millisecond. You get the point? It's far bit slower to do this kind of stuff. And what you need to understand is the difference is you are on your home in London, you go on the side of the street, get a pint in the pub. You know, when in Paris, I'm making the example with taking the bread at the corner of the street, but we're in London, people drink beer at the pint, at the pub. And the difference there is you can go to the angle of the street getting a pint, or you can go to Heathrow, get a plane, go to Australia, get a pint in Australia. It's exactly the same thing. It's far, way slower to speak to the memory, and the network is not on the same scale. So that's why people need to understand that phantasma on low level is really misplaced. When we say low level is fast, it's not true. Who think Go is a low level language? Don't be ashamed. Go have a garbage collector. It's not low level. In fact, Go have a very bad garbage collector, for example. And if you're looking at that, the garbage collector of Go is slow. So basically what's happening is each time you will build something, you will have Go garbage collector saying, I stop the world, who is still used, okay, still becoming, like the old Java garbage collector. But the point with that is, with the old Linux low-level dark magic, you need to understand that if your container ensures security running a userland and not kernel-land stuff, which is written in Go, will actually make the limit pass through, and the Go have to sometime just stop the world and see in the memory what is still used or not, we will be way slower than something in kernel land. That's why all the benchmarks are very false on that, because I/O is a very complex system on performances. And you don't want to run what CPU does when you compare the performance on virtual machine and container, but what actually I/O is, okay? There is a number of other things people don't say to you, like Alpine Linux, for example. Alpine Linux is so cool because it's so small. So when I work in the Starbucks cafe with a shitty Wi-Fi, I can still making Docker. Why it's so small? Or because they strap everything you don't need. Yeah, that's it. Alpine Linux is scrapping the glibc and instead put muzzle, which is made by 3 people, and it's a source replacement of the glibc. I totally trust you when you say I want the same thing from the laptop of the developer to the production. And it has to be the same code all the way. But the question I ask is, do you think the people building JDK, Postgres, MySQL, and Redis test their software against the glibc or muzzle? Actually, when you're using Alpine, your test will be better, sure, but the test of all the frameworks and middleware you used are less than good because you're actually breaking hurt of your operating system. So all this low-level stuff needs to be clearly thinking. So I will pass through that. And I say, before thinking of containering everything into giant binaries and say giant binaries everywhere will save the world, just remember a few stuff. When we're making DevOps, we are not making developer making the job of the ops. We're making developer working with the ops. If you are a developer and creating Dockerfile, basically you're taking the job of the ops, and you're not competent with that. In the world, there is a change through the time. In the 12th century, you have one man in the castle. He was a man speaking Latin, and it was a man creating the bookkeepings, reading in the stars of future, and basically knowing everything that the people know. But today, it's not the same man who actually made electric car, launch fusée through the airspace, and oh fuck, it's the same man. But in normal words, you have different people knowing different stuff. If, as a developer, you take the job of the ops, you're in the wrong way of the history. We all become experts. We're not becoming people who know everything. So if you're making DevOps against ops, it's not the way. You need to work together. And remember, after the talk, I'm so sorry for all the demo breaks, but containers are not small virtual machines. And the container isolation is less good than Apache HTTP on shared hosting. So don't use it on shared environment. Don't use it with third-party code. You need to stay on virtual machine for that, or on separate hardware, like the failure of Meltdown just recall us at the beginning of the year. Sharing stuff is the possibility of exposure. The dark magic of low-level system is complex. If you want to become Docker experts, the first thing is read the news of the kernel. There is a very good website called Kernel Newbies. Kernel Newbies makes you all the news of the developer of the kernel community human readable, because the main list of the kernel is not human readable. So that's it. Using container is good environment, like CI is very nice, and nothing will save the world. If the problem of your IT is applications are old, the UI is ugly because nobody wants to afford a designer, and the old stack is bloated because organization and nobody wants to speak to each other, putting Docker in the middle of the things will not change anything. You need to change your process, not the tools. So thanks you for listening. I'm really sorry about the demo. And I'm creating you a new, it thinks like, okay, I have creating you a new coupon for Clever Cloud if you want. It will be this one. And I'm available if you have free questions, and you have cool stickers if you want. Thank you.